Buongiorno Giulio.
Ciao Damiano, mi senti?
Sì, adesso mi muto perché sono su 10 stanze.
Ok.
Giulio.
Good morning.
Good morning, Giulio. I'm here. I think you are my assistant.
Yeah, right.
See you. Thank you.
Anna Cristina, right?
Yes. Some problems with the net.
Nice to meet you.
But I think it's solved now.
Yeah.
I will start the session in presence.
That's great.
I don't.
Okay. Just one reminder.
Yes.
Before you start, I will send you on your email the link for the evaluation of the papers of the session. So you can do it anytime after the session.
Okay. You send by the email, right?
Yeah, I will look for your institutional email and send it.
Okay. Thank you. I will start my
Thank you very
session.
much. Yeah.
Apaga-se ali, eu apago, deixa estar. No one will sleep. So I asked for the first speaker, I think he's not there. Angela Giolone or Pedro Petruso. No. I know this is not my room. Nadia, Maxwell, and Susan. Not here. The first. Estão aqui as apresentações. Estão a ver esta pasta CAS4A? Está aqui, a tua é PDF, não é? E a tua também, não é, Isabel? Sim, mas estão as duas. Eu pus... Arminda Manuela tem PowerPoint. Não sabia se tinhas animação ou não e então pus. Ok. Ah, mas olha que eu tive para aqui a pôr tudo com animações. Ok. É grego. É turco. É turco. O disco também ficou assim. Não é do template. O template está automaticamente a traduzir. Don't worry. I think everything is in English, but the template name of the international ICCSA is in Turkish. So we go to start this first session of I want to acknowledge people, those people, the area. The first speaker is missing. if you are here to this paper meeting, and I pass to the next, that it was me to present one paper of my student, and I will try to do my best to present this work. So, this work is entitled The Living of Separate Outcome to a web application using multimodal logic regression models. So, we start to talk here, if you don't mind. Não dá para fazer. Não dá, está muito curto. Okay. Okay. So this is the outline of the presentation. I will start with an introduction and a bit.
Anna Cristina.
Object. Yes.
Excuse me. We cannot see it online.
I can wait. Wait, Julio. I need to share here.
Yeah.
And now entire screen.
Yeah,
Yes.
it's the best view.
I need to select this. And now?
Okay. Now you can click on hide just to remove the.
It's okay like that?
Okay. Almost. So first click on hide, please.
On?
Yeah, hide.
Hide.
Yeah.
This?
And now display settings.
Settings?
Display settings on the top left.
Display settings,
Yeah.
yes. Duplicate?
And now, yeah, or swap presenter view and slideshow. You choose.
Swap the presenter view. No, I don't like this. Oh, gente. Now it's okay?
Perfect. Thank you.
Okay, thank you, Julio.
Thank you.
So, after this little technical problems, I will outline of this presentation. We begin by an introduction and the main objectives of the work, presenting the material and methods used, as well the results, and finally the principal conclusions that we achieved. So, we know, it's well known, that the obstetrics play a crucial role in the maternal and fetal health. So, with a significant impact on the pregnancy outcome, we are interested to define or predict the outcome based on some parameters, the central parameters in the health for the mother. Crucial for the providing the proper and personalized medical care during the gestation. So this conducts to the reduced harm, improve the results, and in the same time optimize the checkout of the triad mother, baby, and right placenta. Sorry. So the principal objectives of this study is to explore the fetal placenta biometrical data during the period of validated pregnancy, understand the obstetric outcomes. Here we work with 3 outcomes, not only death or alive. We have 3 kind of outcomes: alive, fetal death, and neonatal death. And we will try to predict this tool using multi-linear regression, as we said in the third object. So we finally, using machine learning techniques and statistic techniques, we use to improve one model based in some measures, accuracy of accuracy, and we implement this model in a web application to use in a practical thing. So, in terms of data set, we have fetal placenta biometrical data collected in CCG Center of Genetic in Portugal, Porto, and we have 2,278 samples initially. The response variable, our outcome, is coded in newborn, as I have already said, in intrauterine fetal death and neonatal death, coded by 0, 1, and 3. The independent variables for this study that are collected are essential fetal placenta biometric features, for example, mother age, gestational age, and fetal weight, fetal gender, placental weight, and all said in this slide. So, to start to construct a model, we need to make a cleanness of the data. And we start for the pre-processing data. We start for remove the duplicate cases and the missing values, evaluate the importance of missing values. As well, the criteria of the sample, the gestational age is not only available for so data cleaning starts values and the duplicate using the R functions. We work in R, and we processing make some calculations and evaluate some possible conflict of variables. And as we work with fetal weight and placental weight and the ratio that the clinical uses from fetal weight and placental weight, we remove the individual variables and we work only with fetal ratio because they have higher relation between them. We use data transformation in the continuous variables. The numerical variables are normalized and the calculated data are created for coded variables, call it dummy variables during the model. So, start what the data tell us after the 2,100 almost samples. We reduce after processing and the cleaning of the data. We reduce the sample, the final sample, to 1,320 samples with 8 variables, independent variables, removing the features that are hyper-related and with some problems of dispersion. So the numerical variables are maternal age, gestational age. The enter 1 and 2 are 2 characteristics of placenta, and we use this in another work that I will talk in the other. We talk about the geniometers, placental thickness, and the ratio of the fetal placenta, and the categorical variables are coded in fetal gender, and we have coded because we work with discretional data, we work with a known who is by two, because we have many samples with discoveries. And sometimes we don't know the gender of the baby. The outcome, as I said, is the newborn, introducing, and the neonatal. I want to highlight your attention for the dimension of the different classes. We are imbalanced classes, and we have a great number of exposed to the newborns, and we have only 26 neonatal deaths. So how we work with this? We use some techniques to balance and some techniques to split data. We start to split data in the traditional way, 70-30 for tests and for training. And after that, we use the techniques modes to balance the data, to try to balance the data. We have made some different iterations, and we think this is the better solution to improve the problem, to improve the measures of the accuracy, essentially. So, after that, what we do, we try to apply the model, our responsible levels. The multi-linearologist is the most accurate method, and then we make the feature selection using different techniques. And after using different techniques, we use the elastic net configuration. We can control with an interparameter training with an alpha and lambda with different values of variation. The assessment metrics used to test the different models was the traditional ones, the area under the cohort curves, and the precision recall, and the traditional accuracy and precision recall, and so the F1 score. After that, we have different models, and I show here, for example, the results of the model for the unbalanced data set and for the small technique balancing. And as you see, only the measures with the smokes, because we have neonatal small percentage small data, we can hide more precision in the small technique. So we use the smokes for the unbalanced data set. After that, we construct models. I said to my students, it is very stressing, and we try to do many work in this, and we have some results. We put here only the 1, 2, 3, 4, 5, 6 models with these conditions. The first one is the model without variable selection with all variables. The model number 4 with rich configuration, the 5 with less configuration, 6 with lambda different from the other, and the 7 with the elastic net configuration with an alpha with 0.1. This is the better. This is not the most great model, but the better for our study. So we use this. The accuracy metrics, as you see, reveals that the best performance is for the model called the mid-7, and with the elastic net configuration. And so we use this because the model struggles with minority class better than the others. In terms of the classes, to comparing the intrauterine neonatal death and the neonatal death, we have different kind of variables. If you see in this graph, for the increase the probability to the inclusion of it, we have the final sets, for example, to decrease the probability to occur this event, we have some variables like larger placental diameters and advanced dish personalization as well, and unknown fetal sets is the condition for the decreased probability. In the neonatal death, the factors that increase the probability to this event is the larger placental diameter because the small diameters cause suppress the baby and sometimes it conditions the newborn. In terms of web application, I think is the most interesting after the choosing the better model. We have the application developed in China, and I try to link, but the network has some problems. I prepare a video for the work. So here I think is the yes. If you want, the application is in this link. You can use this link to access directly to the application. But here I will work with a video because the problems with the net. And so as you can see, generally we have here a banner with three different menus. The home page is the descriptive of the application. This is natural because it's a lady posted to this page. And some information about the construction and the authors and the package usage of the application. When we want this is the main contact, and when we can put the data, we there was an error, and the application and this is the possible values, and because we have a fetal placental ratio, we use the values of fetal weight and placental weight to automatically the application calculates the ratio. After that, we use the button to go. What happened? Sorry. So I skip this part, but I want to show you. Here we are here. If we put the confirm button, they give the numbers that we introduce, and after that, we estimate the probability, and we press the button to estimate, and then they have a light colors, and the orange indicate that the probability, the great probability is the neonatal death for these conditions. This is a light indicator for the clinical is better to see what would happen with this measure. What this implies? In terms of conclusions, we construct a model and we evaluate the performance of the model. The performance seems well done, and but we have some changes in the indication because we we have reduced values of with neonatal deaths. This is the most problem. And in terms of right, with some data sets, tests, and other visual techniques to see what we don't, and the volatility, principally in the unbalanced data. So, sorry for the, and I want to thank for your attention and questions. This is my class. If you have any answer, any question. Okay. Yes.
First of all, congratulations for the presentation. It was very interesting. And the education is really helpful, I believe.
Yes.
And my
anyone can use it, but only the knowledge of the figures, like diameters of the data, like the others evaluate and so on. Only the clinician should know this in the ecographic evaluation. The pregnancy would say the gestational age, no more than
no more than the other.
Maybe only in normalization, if in the data
Pre-processing.
you wave normalization.
We use only the standardized normalization, the traditional standardized normalization to make the impact. Not, we can use it, not, we can use the others. There are other possibilities. It's a normalization. The thing only connected.
My topic is explainability. My advice for the work with of what is the best. If I reduce the input, I think is the future for the.
Thank you. So we pass to the next presentation. The presenter is Isabel Dimas, and she will present the work and title that she said better than me.
Dá-me empurrar.
Dá, sim, senhora.
Vamos para assinalar.
Dá.
Vou também colocar no último da parte.
Ok, mas dá, para tens aqui o ratinho.
É? Dá para assinalar.
Para depois ir uma da apresentação. So, when you are ready, you can start.
So, hello, good morning, everyone. My name is Isabel Dimas, and I'm going to present a work that was developed in collaboration with Karma Lama, which was a former, which is a former PhD student, but with whom I continue to work in topics related to the role of trust in the workplace. So this is a work within the topic of social sciences and applied structural equation modeling. So the mediating role of occupational self-efficacy in the relationship between perceived trust and work is our title. I will start by introducing the variables that we will explore in the conceptual model, and then I will present the methods that we implemented to test our conceptual model. I will present and discuss the results, and I will finish with some takeaways that resulted from the conclusions of our work. So basically, this study examines the indirect influence of employees' perception regarding their leaders' trust in them on their work engagement through occupational self-efficacy. So the focus of our study is exploring how leaders' trust in employees, perceived by employees, impacts their levels of work engagement and occupational self-efficacy, specifically exploring the indirect influence of leaders' trust in work engagement. And why the indirect influence? Because trust signals are not explicit. Trust is an intention, so it's internal to the individual. And to perceive trust, trust needs to be displayed and need to be interpreted by people that receive trust. So trust signals are not explicit, requires personal understand and interpret the trust signals through behaviors. So basically this is the idea. So with the stress to translate in work engagement, it requires personal resources such as occupational self-efficacy, and now I will describe or define each one of these variables. So trust is the level of confidence and reliance on another person's ability to fulfill abilities, and it has a cognitive dimension, which is related to our belief in another person's competencies and abilities, and an affective dimension, which is related to our confidence on support and the extent to which we believe that the other people will be there for us. Perceived trust is the level of in them. Occupational mediator is a domain-specific type of self-efficacy and concerns the individual belief in their own abilities to perform and to have and to succeed in the workplace. One of the main sources of self-efficacy is social persuasion. So it is one of the sources of our belief in ourselves. The way, the extent to which the other people convince us that we have the abilities to perform a specific task. Basically, what we defend is that trust will serve as social persuasion, because when trust is translated to behaviors, then it is a way to convince other people that they have the abilities to perform a given task. So it's a form of social persuasion. One of our first hypotheses is then based on this. Basically, the perceived trust will have an impact on occupational self-efficacy, positive impact. So when we perceive that others trust on us, that will serve as social persuasion, and we will convince our form. So this will lead. Besides expecting that trust will, we also expect that people in their will be more engaged, they will be more committed, and engagement is a state that involves energy, dedication, and work. So when we perform a task, we will be. So basically, we expect occupational self-efficacy will positively impact work engagement. So this is our second hypothesis. And our last hypothesis, which is actually the core of our presentation, of the indirect influence. So if trust will indirect engagement through their self-efficacy. So we can increase self-efficacy on work engagement through perceived trust. So this is the complete model. Here represented with the hypothesis 3. But to have an idea about this is the figure that best represents our work. So turning now to test this model, this conceptual model, we conducted a quantitative study, and data was collected in 2 waves. This means that we separated the data collection in 2 moments. This is why, to reduce common method variance, which is a threat when we collect data from the same participant, because they tend to respond in a given way. So if we separate data collection, we will reduce common method. It's one of the strategies to reduce common method and to increase the internal validity of the study. So the studies were separated to in time 1 we collected data on and occupational safety. 2 we collected data in work engagement. The final sample was composed of 33 from 3 companies. The mean age is 34 years, and he had an academic high degree. The measures, so to evaluate these 3 main variables, we used pre-validated scales. The references are there, but I will not explain. Just to say that the first, regarding trust, is a 5-point Likert scale, and the other 2 is a 6-point Likert scale. This is important because of the means and the standard deviations. So regarding the results, basically, when we need to test a conceptual model, there are 2 steps that we need to perform. First, we need to test the measurement validity, the validity of the measures, to test the discriminant and the convergent validity of the measures. And in this step, we need to test the conceptual model. Okay? So first we will look at the measurement model. We tested the measurement model. But there is there in the slide we have the fit indexes of the measurement model. So CFEI was 0.95. It should be higher than 0.90. This is a good result. RAMSA is 0.05. It should be above, below 0.10. The best is below 0.07. So this is also a good result. We also compare the fit indices of the 4-factor model with 3 other possibilities to see if the 4-factor was the best solution for our measurement model, and the deltas of the chi-square were all significant, which means that the 4-factor model is the best solution to represent the measurement model. So this is just regarding the measurement model. Still regarding the measurement model, we also explore the convergent validity of our variables. So the alpha Cronbach was above 0.60, 0.70, which is a good number, and all variables also had a composite reliability above 0.70, which is also good, and the average variation extracted, which is basically the percentage of variance of the items that is explained by the factor, was above 0.50, which is also a good result. So basically, regarding convergent validity, our model has good psychometric qualities. We have also in this figure the standard deviations and the mean of our variables, and also the correlation, the bivariate correlations were also positive. Were all positive as predicted, basically. Okay, and now we will then present the results regarding the conceptual model. So this is just the preliminary analysis. Now let's look to the hypothesis testing. I just put there the results of the path and the fit indexes, which are in the slide above, so below. The CFEI was 0.98, a very good result. RMSA, again, good. As predicted, cognitive trust had a positive effect on occupational self-efficacy, while the impact of effective trust was not significant. So this means that our first hypothesis was partially supported. Then the impact of occupational self-efficacy on work engagement was significant and with a strong effect. Then the indirect effect, which was our main focus in this study, was significant for cognitive trust, 0.28, and not for effective trust. Just to explain that, because since you are from statistics, it is interesting to understand this fact. I mean, we tested an indirect effect, but by multiplying the path between the independent variable to the mediator by the path between the occupational self-efficacy to work engagement, and to test the significance of this multiplication. Okay, so overall, our hypothesis was supported, except for effective trust. So all the main result of the main conclusion of our work is that, okay, there is a positive association between cognitive trust and occupational self-efficacy. And this survey has positive feedback. So when leaders trust in their employees regarding their abilities to perform a given task, employees will feel more capable to performing the tasks. And this is not true for effective trust, and it makes sense because self-efficacy is more related to our abilities and competencies. So it's more related to cognitive trust, while effective trust is more related to support, and so less related to our perception regarding our competencies and abilities. There is also a strong positive relationship between occupational self-efficacy and work engagement, which also supports our study, our predictions. And the focus of our study, there is actually an indirect influence because for trust need to be understood by individuals to have an impact. So basically, because trust is an intention, is internal to the individual, to have an impact, it needs to be internalized by employees through their personal resources, such as self-efficacy. So this is basically these results were never was never tested. So this is one of the main takeaways of our study. In terms of applications to practice, so basically trust is a very important construct in the workplace. So since it has an important impact on employees, we need to translate our levels, leaders need to translate their levels of trust into behaviors in order to be perceived by employees. So timely and constructive feedback, collecting data on trust assessments, evaluating engagements through employee engagement surveys are some of the applications of our study to practice. Although this study has interesting findings and contributions, theoretical contributions, it also has some limitations that should be highlighted. Namely, the fact that we adopted pre-validated scales, which is of course a positive thing, but it has also a drawback, which is the fact that we limit our ability to collect information. If we, for instance, have collected more rich information, such as through focus groups or qualitative interviews, we could have more rich information. And this is an idea, a clue for further studies. And another limitation is the use of single source data, although we have separated the data collection to reduce common method variance. Anyway, it is also always better to have data collected from different sources and not just from the employee to increase the internal validity of the study. So thank you for your attention. Have questions? Yeah.
Did you apply these models on?
I forgot that.
Yes, yes or not?
We use AMUS, which is an application of it's not SPSS. It's a different package. It's even paid. But we need to have SPSS. We use AMUS and we use Stata. We use both, but I present the results from AMUS. In this study.
It's a hard work, yes.
It is. But we use both AMUS and Stata because sometimes there is slight differences. And since we didn't find a significant relationship regarding the effective stress, we thought that maybe with Stata, because it's a little bit more, we could find that, but we didn't. So we reported the results of AMUS. Yes, traditionally we use AMUS, although we use Stata always for hierarchical analysis.
The software more used by the economy.
Yeah, we use a lot. Yes, yes, yes. And also, I'm also comfortable with R, and I use also R for specific analysis. But for conceptual models, or either I use AMUS or Stata. I forgot.
I think is the best solution for this kind of.
For
this question is
not so good. I also believe that. Yeah.
Not so complete. Yes, it's so complete.
Yes, I believe so.
Thank you, Isabel.
Thank you so much.
Thank you. Now we have the other presentation from Daniela Braga and Roberto Nogueira, telling again about the placenta problems.
Please.
So You can discuss. So let's start with another presentation. Here, I intend to talk about an idea that we have to construct percentile curves based on placenta parameters, parametric parameters that I talked before. This is a work done by one master student of mine, supervisor and sort of Nogueira, Daniela, that she was already finished. And the work was entitled Development of Reference Percentile Growths Curves for Placental Parameters Using Advanced Statistical Models. So, what you know what is the placental? The placental is the first organ developed in the human body, and there are some characteristics that confer the ability to support the life of the fetus in the gestational period. The placental has a great clinical thing. The placental could have a great impact in the pregnancy outcomes, just as said before in the last work, with some biometric parameters that result from this work that were the first work after them. By other way, the placenta, just as I said before, is the first fetal organ to develop. So I think it's important, and we think it's important to establish to the clinicals not only an hypothesis to see how how some biometrical parameters measure not usual measure in the ecographic days consults, but they have the possibility to measure this kind of parameters. So, some parameters that we have and that are important to this study, the shape and the size of the placenta could be associated with the pregnancy complications already studied, like some 21 trisomic and some other genetic disorders could be evaluated using some parameters of the shape, of the size of the placenta, but only in the pathological way. So we think regulation, the monitoring for early recognition of fetal disorders could be, and we try to use that. The placental is normally undertaken, and the most interesting for the community is the correct development of the fetus. But sometimes it's interesting to see around this and see who supports the fetus. So we think the placenta is equally vital for the good health of the child. So, as you know, almost of the people here in this room are females. You have the historical clinical of your babies, and you register in the clinical consults the percentile of the evolution of your child. So we see if we have this kind of evolution, we can predict in the mother in the gestational age evolution some kind of parameters that contribute to the wellness of the fetus. So, based on this, we think this is a great motivation to early recognition of fetal disorders and support the families to decide what happened with the evolution of the fetus, and by other way, enhance the perinatal success rates of the results, not to contribute for fewer classes of neonatal deaths and fetal deaths. So the goal of this work is supporting in one question. Have you ever questioned how we can gain a deeper understanding of placental growth during the pregnancy and its critical clinical implications? So based on this, we think the primary goal is to improve early detection of the result. Based, we try to developing accurate placental growth curve based on the information of the fetal growth and evaluating using complex statistical models like generalized predictive models for location, scale, and shape, and use the better model for each parameter. So, based on this, we explore the clinical significance of placental growth, the main objective. The data set is collected, as I said, at the Embryo Fetal Pathology Laboratory in Oporto, Portugal. They collect 2,064 samples of all hospitals in Portugal. And based on this, I have here an example from the measures of the placenta grew in microscopic way in the pathological laboratory, and what could be done implemented by ways. This is the way to measure the placental weight, placental diameters, and the thickness and the volume is another parameter. And in the echographic field image, we can produce or translate this like pointed in this slide, like D1 and D2. For biometric parameters, not statistical parameters, we use diameter 1, 2, placental thickness, placental weight, placental volume, and to intend to proceed to the other study, the fetal weight and placental weight ratio. So, based on this, we review the methods for constructing growth curves used in the literature, based on some selection criteria initiated in this list, like accuracy in estimating percentiles, the evaluation, the ability to address the characteristics of these distributions, efficiency, and so on. Based on this, we saw some methods available in the literature, like the GAMLSS, the LMSS, LSP, and LNSP. These are the traditional methods used to construct the evolution along some parameter like gestational age or the age of the child in the case of percentile curves for the child. So, in terms of GAMLS, what we know? We know that is a semi-parametric regression type model. This is a great reason for the use. They can allow the access to the different and great volume of distributions. And by other way, it could the integration of non-parametric smoothing terms, and by other, this allows the dynamic modeling of the distribution parameters of the model, now the statistical parameters. Here, the most usual distribution uses in the GMLS models that are implemented in R, they are some particularities for the general model, and we test different models for the different biometric parameters, and we choose the best model based on accuracy measures as well. So the framework construct to do this work, we use some smoothing functions like like analyzing univariate methods, like B-splines and cubic splines, implemented, all these methods are implemented in package in R. And we use the package and we saw what functions, what the package that go to break off. The other smoothing functions are the locally or non-quadratic penalty methods. And with this, we're using a collection of distributions like Box-Cox and Box-Cox-T, and Box-Cox always mentioned the most useful in the growth curves. Based on this, the goodness of fit criteria to decide what is the better model that we use the determination of R squared, the traditional square, the quality measures, the mean square error, and the archaic information criteria, and the BIKE. This is the different adjustment of the criteria. And so on, the plot methods, these are the statistic methods evaluated, and this is some graphic methods used to test the performance of models, the models like the statistic, worm plots, and the traditional residual plots, as you know, the same in the parametric models. So, to start, we have here, we need to have some reflection of the general observability. To decide if we need to construct different or categorize different curves to the fetal male and the fetal female or unknown. Here we exclude the unknown because we are interested to define what happened with the sex if we need to categorize. So we only define the binary classification, and only in several points we have detected some parameters difference in some gestational age, statistical difference, but we intend that this is not necessary to disaggregate the gender. So we construct firstly the growth curve for all fetus independent of the sex of the baby. So here are some preliminary results. Just we said that the numbers are discovered. To evaluate of the parameters, the biometric parameters, as you see, the means and well the median. But we are interested in the skewness and causes parameter statistics. If you see for the percentile volume, so for this methodology, the central volume, the all here is in terms of the placental parameter, the model that works better. Placental parameter ones we use the GAMLS, and for example, for placental diameter, we use the GLMS, and for the others, we use the LMST. There are simpler. As you see, the R square of holes, and it's to construct our growth curves. In terms of the kind of measures that could be, if you saw the distribution of the points between the confidence intervals and in the middle line, you can see that the model fits well, that there are no problems with the residuals. Of this graph illustrates this, and the residual plots reveals the normality of the plots, but some scars, some dispersion with here with the cursor I try to do with the mouse. in the first graph, to indicate some kind of no homogeneity of the residue, because this is not a problem for this model. It is a semi-parametric model. So, in terms to confirm that our curves could be applied to our empirical data, we use the nominal percentiles and the percentiles calculated above. And as you see, the concordance of the values, the 10 percentile, for example, the closest values of each parameter, you saw that the model fits well and could be used to construct our growth curves. And what we intend to with the construction of these curves. As you see, for example, for the placental weight, as you know, as the gestational age increases, the placental weight increases too. So all graphs translate this behavior. And what the meaning for the clinical percentile 3 in diameter 2, for example. This means that if the 20 weeks, for example, of gestational age, we have a percentage 3, in diameter, the fetus could have problems in developing age. So the clinical could intervene in the mother to get better the result of the pregnancy. And here is the growth curves that we design with these models for the other biometric parameters. In terms of conclusions, we have research highlighted vital the use of the placental growth with the globe accurate placental growth curves. Just you can see by nominal and the estimated percentiles of the table in the table using models GAM, LS, and LMST. Need for future investigation in these fields, yes, is a potential to enhance recognition of fetal disorders. We can use this to do. The clinicals today use tables, the traditional tables of percentiles to decide or to evaluate the situation. We try, they are always construct an application that the clinical can find of the gestational age, the placenta, the placental parameter, and see what happened with the fetus, and can decide the outcome or can interfere in the outcome. The goal is to develop a Shiny application is all in progress, and for conclude, we think the final success result will always not only the child, not only the mother, not only diet of these 3 factors will be contribute to the wellness of the child. Thank you for your So, questions?
Again, very interesting your question. Yeah, but it's very interesting actually. From my experience, they focus too much on the mother and on the evolution of the
organ that is important.
And never in the my question is just a curiosity because in the first 8 weeks of the weeks we saw a slight decrease, right? Yeah. So it means that the parameters decrease in terms of quality at the end of the weeks?
No, some parameters have this behavior and the others sometimes cross each other in the percentile curves. These methods, LMS, LMST, have different particularities to conduct the behavior of the percentile. If we have some different behavior in the last weeks, and the first is essential these points, we have fewer data that we think that with more data we can induce the same behavior of the girls. Not the girls, exponential girls, they have different distribution for each one. So, if you have no more questions, we pass to the last but not the least, the traditional way to say. Elisa Manuela to present work.
Este rato não está a funcionar, afinal. Tá, tá. Vamos lá outra. Como é que é? Escape? Muito bem. Estou cansada. Queres que te vire assim? Quero. Então. Tens mais plateia ali, é claro. É, o pessoal também. Os óculos. Oh, ainda por cima são os nossos lá. Okay. Good morning, everyone. My name is Manuela Gonçalves, and this work was made with a master student, Ângelo Cunha. We have a master named Master in Statistics for Science, Data Science, in the University of Minho, in Department of Mathematics in Portugal. Okay, this work was made in the context of internship by the student in an international insurance company named Grupo Atureal in Portugal. Okay, I will start by the company, presenting the company, motivation and goals. This company, Grupo Atureal, founded in 1995, involves service of insurance companies and pension funds. They work in both life and non-life insurance. They are present in 23 countries, with headquarters in Lisbon and an office in Dubai. The main areas of operations are actuarial service, development of management software, and pension fund management. I go to focus on goals. Here we have many points of goals, but I will only focus on identify the best. We want identify the best performing models while ensuring they remain practical for actuarially and regulatory applications. Okay, accurate premium estimation is fundamental in insurance pricing, ensuring both fairness for policyholders and financial stability for insurance. This study focuses on individual health insuring pricing. Traditional, these companies works with generalized linear models. But in the first time with this student in this company, we applied machine learning techniques, specifically decision trees, random forest, gradient boosting, GBM, and XGBoost. From the start, we have to think a little about the main advantage and the main disadvantage between statistical models and machine learning. And in my opinion, the main advantage of statistical models are easy to interpret, requires an understanding of data, statistical more robust, establish a reproducible relationship. Machine learning, easily to identify patterns and trends, automatic methods in continuous learning, processing multidimensional and multivariate data. In our case, we have a big data set. This advantage may not work well on large data sets, like our case, strong assumptions, prior selection of covariates. Main disadvantage of machine learning, data acquisition, much time and much resources. And you always have the problem of interpretation of results. So the pricing, the fundamental concepts. We have these main variables: exposure, measure of risk assumed by the insurer concerning the policyholder during a specific period. Exposure is often associated with the time the policy is active. Frequency of claim, number of claims incurred in policy I per unit for exposure and I, and severity of the claim. I will represent by a Xij, which represents the total loss value of the J claim incurred by policy I. And the pure premium. What is the pure premium? Is the portion of the insurance premium that covers only the expected losses and related expenses. So, the pure premium is obtained, consider SI to be the total. Oh, sorry. Next. Before. Okay. Is the sum of Xij and the individual expected loss. Here is not I. Where is I is J. The individual expected loss, also known as the individual poor prime, is the product between the expected value of Ni and the expected value of Xi. Pure premium is a standard term in insurance representing the expected cost of claims, the product between frequency and severity, without including profit margins or administrative costs. So I'm going to present in a summary way the data set. We have we consider for developing the models 9 variables. First, for confidentiality reasons, we had to anonymize the data. And we consider 233,745 individual health insurance policies. We have as variables exposure, age. We first categorized many variables: gender, benefit type, region, commercial premium, sum insured, incurred claims, number of claims, etc. Okay. Now, the response variables, the outcomes. We consider the number of claims, the frequency model, the incurred claims, the severity model, and an auxiliary variable exposure, offset variable. Number of claims representing the count of claims reported per policyholders, incurred claims, the total monetary amount paid in claims per policyholders. Exposure represents the total duration of risk coverage per policyholder and serves as an offset variable in GLM. Adjust claim frequency for varying policy durations. We consider 1 year is the traditional time considered. But for the number of claims, we can see the standard deviation clear exceeds the mean. We have to think, we have to handle with over dispersion. The maximum is observed for the frequency 0. I will skip the details because I don't have time. For incurred claims, for example, we have we categorize the data in this way, and again we have the maximum value in 0, and we have here a right screened continuous distribution. This is important because we have to think when we go to apply GLM, we have to consider gamma distribution, inverse gamma distribution, inverse normal distribution, etc., etc. Now the exposure The exposure we categorize this way. You have to think the maximum is 1 year, okay? When I said 0.2 is 0.2 of a year. The exposure is adjusting for is crucial because as policies with longer coverage periods are naturally more likely to generate claims than those with shorter durations. Incorporate exposure as an offset variable in GLMs ensures that claim frequencies are evaluated on a per unit time basis, preventing bias in the estimation of risk factors. The age band, gender, benefit type, region, I will skip this slide. And we, in exploratory data analysis, we calculated also the correlation data matrix. Now, the application of GLM pricing models. Here we only present some models. We try many models, and we decided the best. We don't get the best models. With the optimal model was selected by AIC, BIC, deviance, residual analysis, model validation, etc. And the interpretation of GLM is very good. In this case, for claim frequency, we can see we applied logarithm. So the first was a product. Now, applying the logarithm, we obtain a sum with the severity and the frequency claim, and we can see a strong positive relationship between age and claim frequency. Individuals aged between 56 and 65 filing approximately to 53 times more claims than those in the first stage. Above the oldest clients, this effect became even more pronounced. Regional variations were also evident in the model. I forgot, but we tried interaction effects between the categorical variables. Okay, regional variations were also evident in the model. The significance of age, benefit type, and region has key factors in insurance pricing. Now the severity. Again, the region, age, and benefit type significantly influence the claim severity. Policyholders from region B had 9% increase in expected claim amounts, whereas those in region C had the 10% decrease, both statistical significant. Age had, again, a strong effect on severity, with claim costs rising as age increases. I go to pass to the pure prime model, and the pure prime model is calculated, just like I said, as the product between the frequency and the severity models. Given that both models are in the form of a log link function, like I said, pass a sum. And now, again, with the quick way, I go to present the machine learning techniques to obtain how much time 5 minutes, okay. I will skip some slides. Machine learning to model the same response variables. So now to apply the machine learning, it is a more demanding and labor-intensive task, because it's very important to provide correct inputs for then to achieve accurate and precise results and outcomes. I think this is the most important task in machine learning. So, cleaning data, we have to, in this pre-processing, apply the different steps: feature engineering, normalization, categorical encoding, handling imbalanced data, like you said. We have to split the sample. We consider 8% for 20% for testing, hyperparameter. And we tried decision tree regression, random forest, gradient boosting machine, and XGBoost. I will skip these details about each method, but they are important. We consider cross-validation. The usual is tenfold. And for comparing models, we applied mean square error, the traditional, means absolute error, averaging of performance metrics from each fold for comprehensive evaluation. Here, the decision tree, the steps, I will skip. I only will read the last lines. Why important? Provides interpretable splits in the data, prevents overfitting by controlling tree size and splits. Random forests. Random forests are robust against overfitting due to randomness in splits and ensemble averaging. Gradient boosting. Optimize performance by correcting previous errors, balance bias variance trade-off effectively. XG boosts. Efficient computation with parallel processing, handles missing values and large data sets effectively. Here we have the results, and for the training set, the best in machine learning, the best models were GBM and XGBoost. For the severity, GBM also, XGBoost also, and surprising, the random forest. We obtain good results also. Here is the same results, but now for the test phase, because we want to forecast and not only to model our response variables. And again, the same results, the methodologies and the machine learning of the statistical models. Superior performance of machine learning models. The main challenge is interpretability, because they are a little a black box. GLMs more transparent, less accurate, but more reliable and transparent. To only is many points, but if I go to start this problem, I think the best models will be the hybrid models. And I never tried this kind of models, but I'm going to study this kind of models because they combining the good things of each methodology. I start with the traditional models, GLM, and then I applied machine learning to balance the disadvantage and the advantage, just I present before in the first slide, the first slides. So, thank you very much for your kind attention.
So I asked for some questions. Some questions? No?
Thank you for your presentation. Very difficult to understand. But I'm curious about the findings. mainly regarding, for instance, the effect of illusion, the range frequency, and
the effects of my student was more
focused on the
but the company, in the first time, the company doesn't like when we said we are going to apply machine learning because they always apply the GM, okay? But in the end, they said, okay, it's a good approach, it's a good strategy, and I think they will start to apply this kind of this is a big company.
they are able to use they are able to use to apply.
Yes, because they are now on people in these policies, maybe our software and
Okay, thank you again, Erlinda, for your presentation. So we finished this session of Computation and Applied Statistics with these works, and I want to thank to all presenters. And we return in the evening, 2 o'clock here in Turkey. I see in online some presenters of the evening. Hello, Luis. Hello, Gustavo, from your presence in the audience. Giulio, I will finish the session.
Yes, perfect, Anna. Thank you very much. And
Thank you,
I sent you the link by email. So
yes,
when you're comfortable.
I will fill the questionnaire and I send the form. Thank you. See you
Thank you very
later.
much again. See you.